Good day everyone, I am Rakiza C. Gaugay. For today's presentation, I'm going to present to you my laboratory activity 8 entitled Test for Acid and Base. And without further ado, let's begin. But before that, let me state first my objectives for this presentation. First is to learn how to distinguish between acids and bases. Second, to discuss and give examples of acids and bases. Third, to differentiate acids and bases. And lastly, but not the least, to discuss the litmus paper of acids and base. Let's start in the question, how to distinguish between acid and bases. In chemistry, the easiest ways to distinguish acids and bases is to look at the substance's pH level. Acids have the pH of less than 7, while bases have a pH greater than 7. But what if you don't happen to have any litmus paper handy? Turns out there are plenty of ways to distinguish between acids and bases that don't require testing the substance. You just have to evaluate its basic properties. Listen on to find out how you can easily distinguish between acids and bases. And now, what are acids and bases? Acids are substances with a pH lower than water. Pure water is a neutral substance with a pH of 7. Any substance with a lower pH is an acid. The lower the pH, the stronger the acid. In chemistry, there are 3 theories further define acids. Number 1 is the Arrhenius theory. According to it, acids are any substances that increase the concentration of hydronium in solution. And number 2 is the Bronsted-Lowry theory. According to it, acids are any substances that can act as proton donors. And number 3 is the Lewis theory. According to the Lewis theory, acids are any substances that can accept a pair of electrons. Now let's proceed to the bases. Bases are substances with a pH greater than water. Any substance that has a pH higher than 7 is a base. The higher the pH, the stronger the base. The same 3 theories that define acids also define bases. Arrhenius theory, according to it, bases are any substances that donate hydroxide ions in a solution. And number 2, the Bronsted-Lowry theory. Bases are any substances capable of accepting a proton, and according to Lewis theory, bases are any substances capable of donating a pair of electrons. And now, let's give an examples of common acids and bases. Citric acid and vinegar are common acids. Acids show up frequently in your body and in the foods you eat. Your stomach uses acid to break down and digest food so your body can use the nutrients in it. Other acids are electrolytes, essential for your body to function. You've probably been encouraged to take vitamin C if you have a cold. Vitamin C is a common name for ascorbic acid, which is found in citrus fruits. Did you know that baking soda and bleach are 2 common bases? Bases aren't as common in your daily life as acids are, but they are often used in cleaning. Soaps are bases, as well as cleaning products that contain bleach or ammonia. Toothpaste is also a base. This is why it tastes so weird to drink orange juice, which contains high levels of citric acid after you just brush your teeth. Differences between acids and bases. And now, let us know the characteristic of an acids. Acids, they're sticky. They taste sour. They have a sickly sweet smell like soured milk. They have a pH of less than 7. And also, they produce hydrogen gas and salt in reaction to metal. And what about the characteristic of a bases? Well, bases, they're slippery. They taste better, they have a pH higher than 7, and they also odorless and capable of neutralizing odors. And what about their differences when it comes to their name? Acids usually have the word acid in their name. Acids are pretty easy to identify this way because they're almost always directly called acids. Think citric acid, amino acid, or folic acid. Some acids do have more common names that leave off the word, though usually you might have to research the substance to find its scientific name. For example, while you've likely heard of vinegar before, you might not know that it's technically acetic acid. So there's the word acid right in the name, although it's not the name most commonly used for the substance. If you're looking at the chemical formula, acids typically start with H. Bases usually have the word hydroxide in their name. This can get tricky because most bases are commonly known by a different name. But if you can track down the scientific name for the substance, it will typically include the word hydroxide in it if it's a base. Carbonates, such as sodium bicarbonate or baking soda, are also bases. For example, ammonia is also known as ammonium hydroxide. The hydroxide part of the name tells you it's a base. You can also look at the chemical formula of the substance. If it's a base, it typically ends with hydroxide. Indicators for testing acid and base. An indicator is a dye that shows a change in color when brought in contact with acids and bases. This tells us whether the substance we are testing is an acid or base with respect to the change of color. The three most common indicators to test for acids and bases are litmus, methyl orange, and phenolphthalein. One of the quickest tests to determine if a solution is an acid or base is the litmus paper test. This involves dipping a special strip of paper known as litmus paper into the solution and observing the color of the paper. Litmus paper will turn red in acid solutions and blue in base solutions. Litmus is a natural indicator. It is a purple dye which is extracted from a type of plant called lichen. There are two types of litmus paper, red litmus paper and blue litmus paper. Blue litmus paper turns red if the substance is acidic. Red litmus paper turns blue if the substance is basic or alkaline. Litmus turns red in acidic solutions and blue in basic solutions. For the generalization for this presentation, acids and bases do not only take place in scientific laboratories. They are used in more places in today's society. Acids and bases are involved in our everyday life and everything from digestion of food to the medicine you take and also in cleaning products you use. And that will be all for my presentation. Once again, I am Marquisa C. Gaugay. I hope you learned something from my video. Thank you for watching.